Hi everyone, how you doing? I hope you're doing all right. I'm doing okay, hanging tight. It's just a little annoying, right? I do miss seeing you guys a lot, but hopefully you're understanding everything that's going on. And hopefully you won't have any trouble with your test tonight. So chapter 5 is the distillation process, and we're going to just cover this in several parts. Part 1 will be the process description. Okay, we're just going to go slightly easy with that. I also want to mention that I have loaded there from your CPO 151 the units on distillation PowerPoints, which if you want to go back and refresh yourself, I don't know if you remember to keep them, but again, they're all there for you to look at. Okay, so we're going to do process description. We're going to define a distillation process. In this also we will list and explain the factors that affect a distillation process. Also, given one factor that affects the distillation process, one of these, we will discuss what other interrelationships are with the other factors. Okay, this is the schematic for figure 5.1 is on page 5-27, and in there it lists all of these. You can see this picture. You also will have an equipment list and instrument list on 529, so you get the names of all these different tags. It's kind of hard to see on here, but you should be able to look at it on in your workbook. Okay. Distillation is the separation of components of a mixture by repeated partial vaporization and condensation. So again, distillation occurs at each stage of the column, all right? And there's so many stages, and you get better and better purification as you go up the column. The difference in the boiling points, the vapor pressure of the components, is necessary for effective separation. Now, if you remember, best separation occurs when we discussed that term relative volatility. Again, that's in 151, and you can go back and look that up. But relative volatility, usually for a binary situation, that's when you have just two components that you're separating. The vapor pressure of one substance is compared to the vapor pressure of another, and that is usually done by the vapor mole fractions and the liquid mole fractions, if you remember that. Again, like I said, you can go look that up. So the differences in the boiling point or the vapor pressure is really important for effective separation. We talked also when the relative volatility is much greater than 1, really large, then you have really, really good separation. Okay, distillation can occur in many different types of columns or towers. We have trays and packing. There's tray columns, which are sieve, bubble cap, and valve, and then a packed column. And as you might remember, the distillation column in our lab is a packed column. Now, we're going to talk about the vapor-liquid contacts. So vapor-liquid contact is necessary for the heat transfer to occur. This heat causes the continually occurring, okay, so at each stage, there's a partial vaporization and a condensation, all right, at each of these stages and tray. So the column internals direct the flow of the liquid and the vapor. In this course, the distillation column will contain sieve trays. These trays are super sieve, flat perforated plates without weirs at the edges. All right, so let's look at this picture here. This is kind of like a sieve tray. However, though, there's a weir here, and there's also these bubble caps. What they're talking about in our text is basically a flat, like if you have a colander at home and you have the holes, right? Although it's curved, right? It's because you're putting your pasta or whatever and you're draining the water through it. Well, just think of that colander flattened out, and you just have all these holes, all right, perforations in the holes, and it's flat. So the liquid just falls off the edge of that column into the next, off the tray, stage into the next, down below to the next stage, and so on. All right, so there are not weirs in this particular column. Okay, the sieve tray distillation column D1 is designed to separate the lighter organics in the feed from the high boilers. The low boilers are again driven overhead and condensed and sent to the storage. If you look at your paper, FI47 indicates that flow. There's a side stream of the overhead product pumped back to the column as reflux, FIC42. Reflux is really important to running the column and making sure that we get really good separation. Vapors are not condensed in the overhead condenser E1 that are not. If they're not fully condensed in E1, they're passed through another condenser E5. Liquid is drained to the overhead distillate surge tank T1. And non-condensables are vented to the flare system to be destroyed. So these are just those gases that just no matter what temperature that you're cooling in E4 or E5, they will not become a liquid. So they just get flared out. Now we have a thermosiphon reboiler. E3 is the heat source for the process. The bottom's material is circulated through the reboiler where about 15% of it is vaporized. The remainder rejoins the liquid in the column bottoms. A side stream of the bottoms is drawn off and pumped to storage, P4. Now I want to explain what a thermosiphon reboiler is. It's another type of a heat exchanger, and it has two phases here, as you can see. All right, and what happens is the liquid falls down here, goes through this. The heating fluid is through these tubes here. Okay, so the liquid goes through the tubes, and the heating is circulating around it and comes out. Usually it's steam. All right, it's a two-phase mixture, and it's discharged back to the tower, where the liquid settles back to the liquid pool, and the vapor passes up the tower. What's nice about the thermosiphon reboiler is that it is less susceptible to fouling problems and in general has a higher heat transfer coefficient than a typical kettle reboiler, which you've heard about probably a lot of times. And ours is a kettle reboiler in the lab. There's this big bowl there where we just have a kettle and we boil that. I just want to mention, I think you should look at this. It's only 19 seconds to look at a thermosiphon reboiler and understand it. 19 seconds, I think you should do it. It's on the other PowerPoint. And you can also click on this afterward later. Also, a 17-minute video on distillation, you might want to look at that. So again, these are available to you in the PowerPoints, the regular PowerPoints on the other page. All right, let's talk about the factors that affect distillation. So in this text, they talk about 3 factors. However, there are way more than that. Okay, so when we look at about the breadth and the scope of this particular troubleshooting, because we can't cover everything, we want to look at these 3 main ones. However, you'll find when we get to the liquid and vapor contact, there are more factors under this that affect this whole process, which is where the rest of them come into play. All right, temperature. So temperature is a critical variable because it is the basic operation that is repeated, heating the liquid to a vapor and condensing the vapors. Okay, so this is constantly always happening in the column. The bottom temperature on the column reflects the heat energy added to the process. The top temperature is the result of the heat removal. So there are overhead and after condensers and reflux put back into the column. A column temperature profile should be evenly distributed from the top to the bottom. What you'll always find in the column, and you should find this when it's working correctly, there's a slight decrease as you rise up the column. Remember, the hottest is at the bottom, and in the low boilers, right, those that boil at a lower temperature come off the top. So the temperature slightly decreases as you go up. So the temperature at each location is the boiling point of that material. So at each stage, okay, you'll have the vapor that comes up, and it's bubbling up here, and it keeps going until you capture that which at that temperature you're running at to get the tops, which is the lowest boilers. Remember, pressure always affects the boiling point. Temperature is often the most valuable information regarding the condition of your column. So if you want to see how your column's running, you look at your temperatures. Okay, pressure. Distillation columns are designed to operate at a specific pressure. Okay, that again affects what? The temperature. The effect of the pressure on the boiling and condensing points always makes the pressure very key, and you have to control that carefully. The high pressure in a column is the bottom, where the heat input is input into the system. Okay, the pressure decreases toward the top of the column, which, right, the decrease is due to the vapor pressure restriction, right, the vapor flow restriction provided by the packing or the trays, and the low pressure point on the column is the top, and this is logical because it's also the low temperature, right? So remember, it goes in line, the pressure profile is in line with the temperature profile. Remember, high temperature, high pressure, low temperature, lower pressures, okay, or low pressure, and then you can boil at a lower temperature. Now we're going to talk about liquid vapor contact. The separation of the components in the distillation column depend on the contact between the liquid and the vapor. The vapor flowing up the column and the liquid flow down the column, and they're made to contact each other by the trays or the packing. So when you get that effective contact, right, heat transfer goes. The heat transfer as a results in partial condensation of the vapor and partial vaporization. Okay, the correct VLE, all right, you have to have enough the trays have enough trays to have the flow so that the correct VLE occurs, the vapor-liquid equilibrium exchange. This causes a more efficient separation as the vapor flow rises and then the liquid flow sinks. Okay, think of it that way. The composition of both vapor and the liquid are changed. The vapor becomes more concentrated. Okay, right? Again, that's the point of this whole distillation, and the liquid becomes more concentrated with the higher boilers. Sorry, vapor low boilers, liquid higher boilers. A number of variables affect the liquid-vapor contact, including temperature and pressure. So here are these other factors that I was talking about. So I guess they just decided they would put them in here. So let's look at them. What's also important for liquid-vapor contact? Feed to your column. The rate of your feed flow is very critical. Plus, if it's preheated, is important. And remember, the feed does not go in the column right at the bottom tray. It's usually fed midstream. External reflux. We have that reflux that comes around to help make the separation even cleaner. The liquid bottoms to the reboiler and vapor from the reboiler to the column. Okay, both high and low levels can negatively affect the ability of the distillation column, right? Liquid levels on the trays or suspended packing is most critical because of the direct impact on the separation. Column bottom level is necessary for flow to the reboiler. Overhead distillate surge tank levels supply liquid for external reflux. Now, another thing that you have to remember is all of these are operational issues that we've learned with the liquid vapor are those areas we talked about. Do you remember the entrainment, whereas high vapor speed and the liquid flow carries it, with that high vapor speed, it carries the liquid into the next tray, so you don't get good separation. You can have foaming. You could have the weeping, where there's a very low vapor flow. And then you can have coning, which is high vapor velocity also, and then flooding. All right, so those were areas that we talked about in 151. If you want to review them, you can look over them again with the slides. Okay, now this was nice and short because you do have your test. So do your distillation, look at self-study questions 5.1. In 5.1, there's the self-study questions. And then I hope you are working on your report. I know you're busy. And the lab that you have in this particular class, we don't have a lab this week because you're taking your test, okay? So again, I'll be downloading the test and sending it to you. It's in a Word, and you can just resubmit it that way. And I appreciate all the time that you spent here continuing to work hard. Remember, this will pay off. All right, just relax, enjoy yourself as much as you can, and have a good rest of the night. All right, you guys, I'll talk to you soon. I miss you.